we're going to start with your formula. Oh. And we're going to transform it so that we get x equals. And we're going to use that formula whenever we have a z-score, a standard deviation, and we want to find the mean, and we want to find the related x to it. Because that's what we're basically getting at. Remember when we said like the top 10% was the probability that it goes in the top 10%? We now want, what is that cutoff score that applies to that? So say you're taking your SATs, and you want to be in the top 10%. The college says top 10% of the scores. I want to know now, what is that cutoff score? That's what my x value is going to be. So I can use this formula, solve for x, and then keep using this all the time. It is the same formula. So all I need you to do is to see that it's the same one. So to get there, we cross multiply. And you want to get x by itself. So you add the mean to both sides. So we get the mean plus this is equal to x. If I just switch these around, there's your formula. This is the formula where, same formula as your z-score. We just solved for a different variable. You don't have to know how to solve for a different variable, but you should at this point know how to transform something. But this is the one we're going to use. If you can give me a z-score and the mean and the standard deviation, I can tell you what your cutoff value is. So we found the standard deviations. We know the mean and standard deviations. We found the areas associated with that z-score. And now I'm going to tell you what is your cutoff in terms of an x value. You'll see it work as we do this. It's page 239. So let's go to example 3 and take a look at this. As soon as you see this, it'll start to make more sense. Because yesterday we were working with your table and working with, finding the values that are associated with those areas. But now you get to put the whole thing together. So we want to find an x value that corresponds to a z-score. The speed of highway vehicles along a stretch of highway are normally distributed. We need to know this. With the mean, you pull out your mean. And a standard deviation, you pull out your standard deviation. We need to find the x that corresponds to a z-score of 1.96, another z-score of negative 2.33, and a z-score of 0. So we look at our chart, our curve. And 1.96, somewhere over here. Negative 2.33, somewhere over here. Our mean is up here. We can figure out our standard deviations all the way up, and we can figure out our standard deviations, subtract them all the way down. In fact, that's probably a better place to start. Let's start like that. Let's do that first. And then you can kind of get to see what this curve looks like. So let's start with your 56. And let's add 4. 60, 4, 68. And then we're going to subtract 4. Okay? So here is negative 2.33. Here is your 0. And 1.96. So I want the x values that correspond to those z-scores. What we were doing the other day is saying, here's your area. What is the z-score associated with this area? Now we're going to take that and we're going to find what is the x value associated with this. I want to know what my cutoff is over here. First of all, my standard deviation of 0, what's my x value? 56. Isn't 56 right here at the 0? So this is the x value up here. This is the x value. This is your standard deviation, your z-scores. So at the 0, I'm at 56. That's my x value. At the 1.96, all I can tell right here is I'm somewhere between 60 and 64. Probably closest to 64 because I'm closest to the 2. But I don't know exactly what it is. So we're going to use your formula. We're going to take your formula and all we're going to do is plug this information in. This is the formula we just transformed. I'm on the bottom of 239. In case you can't see this and you want to look a little closer, this is the problem on the bottom of 239. So we take your mean, we take your z-score, and we multiply it by your standard deviation. This gives you the x value that corresponds to that. This is the reverse of what we normally do. Normally we say, find me the z-score. We say the x minus the mean over the standard deviation. We find the z-score. This is reversed. So when you find this, this is going to be 63.84 miles per hour. Okay? And we said it would be real close to the 64. This is the x value that corresponds to that. If I want to find the negative 2.33, I do the same formula again. This is a nice little transformed formula. You can put it into the original z-score, but you have to keep working with it each time. So we take your mean, we take your standard deviation, we multiply it, or your z-score, we multiply it by your standard deviation. And we come out with 46.68 miles per hour. And we said that would be somewhere between 44 and 48, so we're right on target with this. So it's important to us because sometimes we're going to say, give me the cutoff for the top 10%. So if I'm looking for the top 10%, how would I do that? How would I find, what procedure do I go to find the cutoff for the top 10% of my speeders here? How would I do this? Put together yesterday and today into one. So what is the first thing I have to do? Certainly get quiet when I ask the question. Hear me. Well, I want the top 10%. Where is this? I want the top 10%. I want to know what speed is my top 10% of my speeders, because I'm about to go after them.
Well, I mean, I wasn't here yesterday, but I mean, between 1 and 1, there's 68%.
There's 68, but I want the top. My percentage go from here
Exactly.
to here.
So then, percentage between 2 and 3, I believe, or something. It's about the percentages.
It's about percentages. Percentages is the area under your curve. So let somebody help me out that was here yesterday. What did we do yesterday? To find, how did we find 10%?
The z-score that correlates to that, right? So
Okay.
9.
But we have a way to do this. Inverse norm, we want this area to be 10%. 0.10. So we did inverse norm. And what did we put into inverse norm? 0.10 will give me this one down here. 1 minus 0.10, because actually we look up the area to the left. If we looked at 0.10, we would get the negative, we just have to turn it into the positive. So let's look up the z-score for this. Oh, I forgot to take the calculator out. Anybody find the z-score for this? Read it to Alyssa. These guys are taking out their calcs. So what's the z-score? Okay, Jan, what'd you get? Okay, so you looked up the inverse norm for 10%, right? Okay, that's okay. You got negative 1.28. But we want the positive, so we're just going to turn it into the positive. Because we want the one on this side. But it's symmetric, so you can look up the negative. But because we placed it on this side, we get the positive. So 10% of our scores fall here. Right? Is that what everybody got? 4.28? Now, I want to find my cutoff of my top 10 for speeders. I want to hit whatever speed they're going. I want to put my top 10 speeders over, 10%. So I say, okay, let me find out what value that is. So I put it into my formula. Here's my mean, here's my z-score, here's my standard deviation. So if somebody could kindly compute this for me, please, and we'll find what speed I need to go after to get the top 10% of my speeders. 61.12, thank you. So I want to go after the people that are going 61 miles per hour or higher. Tell them they're speeding on my road. Okay? I want the top 10%. This is what we use this whole process for. Well, you want to find the exact value of an X value. And you know the area under your curve, or you know the z-score, and you know your mean and your standard deviation. This is what we're heading for. This is what is used in a lot of businesses. Top 10% of your salaries. You take the top 10% of your salaries. Let me see where my cutoff is, what my X value is. If you're looking at going into, getting hired, you want to know, like, what are your top salaries? Give me your top 10% of your salaries. Where's your cutoff? I eventually want to make sure I get close to that. Maybe I want to be right now when I start in my lower 20%. Maybe I want to be under 50%. And that's where I look for my cutoff. For now, you guys try this one. Okay, so for your z-score of negative 0.75, you should come up with an X value somewhere between 62 and 70, probably closer to 62, right? What'd you get? 64. 64? Everybody gets 64? So you use your formula. This is a nice way to reverse your process to find what was my cutoff over here for this guy. So I plug in my mean plus my z-score times my standard deviation. And we come out with 64. Okay, these are the monthly bills for your utility. So what would cost about $70 on average, this one is $64. For this guy, we don't even have this registered on our chart, but let's see what happens to this. We plug this in, just plug it in like you normally would. Because this does go on and on and on. We don't calculate more than 3.49, but it still goes on and on and on. So we expect it to be somewhere over 94, right? 104.32. Thank you. So a little off our chart there. This person has high utility bills. And for the last one, 1.82, somewhere over here. So we plug in our formula. Oops, negative 1.82. Sorry, negative 1.82. Somewhere over here, not here. So we plug in our formula with negative 1.82. Temperature standard deviation. So we expect it to be somewhere between 54 and 62. What do we get? 55.44.
Circle lesson actually gives you like not like a curve, but a chart kind of like that, like what percentage you are and like
What gives you that one?
central lesson like when you clear.
Yes,
Yeah.
you get that and tells you if you're a good efficiency.
Yeah.
Yeah.
We're off the charts. It's like neighbors, and then like we're not.
And see, in the winter, I'm the good one. In the summer, I'm the bad one. In the winter, I never use my heat, but in the summer, my kids crank up that air conditioning.
Yep.
So I just got my efficiency rating. They do. They give you a percentage. And it's not the percentage that you use, it's your ranking in your neighborhood. And they rank you to say, are you in good efficiency, poor efficiency, you're off the charts efficiency. So you get those every couple of months. That's true. Okay? All right. So let's look at our top scores. Scores for a civil service exam are normally distributed, we need to know this, with a mean of 75 and a standard deviation of 6.5. To be eligible for the civil service, any employment anywhere, they take all the results of this exam and they take the top 5% of the scorers. Because a lot of people take the civil service exam. So they've got to have a cutoff spot. So they say, give me the top 5%. So now, as an employer that uses the civil service exam, I need to know what is the cutoff score that I need to look at. So I want to find that X value associated with the top 5%. The top 5% is the area that has 5% in it to the right, right? So here's my mean. I run my 1, 2, 3, and my -1, my -2, my -3. And it's going to be tough because it's 0.5. It's a good thing in the beginning to use your graph. It really does help you make sense out of your numbers.
It's 81.5, 88, and 9.5.
Thank you. And 9,
9.4.
thank you.
And on the other side, it's 68.5, 62,
55. Thank you, Lizzie. Okay, so we're good to go. So we want the top 5%. How do I find the z-score for the top 5%? I need to know my z-score first for this guy.
Inverse of 0.05.
Okay, if I do inverse norm, okay, we can do this. We get the negative, but we just take the positive. Or we can do this, 1 minus this, and that'll give us exactly the positive. Does everybody see they're exact same because of the symmetry in your curve? So what do we get for a cutoff score, a cutoff z-score? Thank you. -1.64, so we're going to turn it into the positive. So we're going to be right in here somewhere. I need to know what X value is associated with this z-score because this is 5% of my area. I want to know when I look at these exams what cutoff one I'm looking at. So now I use my formula. It's just a transformation of your z-score. But it makes it more convenient to plug it in this way rather than use your z-score formula. So we take your mean, we take your standard deviation, and your z-score, and we just multiply those guys. And we come up with our cutoff point. So now as the employer, I need to find anybody that has a score of 85.69 or higher. Anybody score below that, I'm going to look at their exam and put it aside. You've got to score at least this or higher. I want the top 5%.
Is that why experience is even higher than above?
They probably, no, I actually hear they make the cutoff grade. This is you basically saying I want the top 5% because each time a group takes a civil service exam, the top 5% may have a different cutoff point. And like we can't always say above 85, above 90. This one we have to base it on the mean and the standard deviation of that group. But here they probably say you're supposed to have a score of 85 and above, to be honest. The top 5, the top 10, I've told you a lot of colleges use that for your SATs. They want the top 10% of their SAT scorers. So they figure out for that group, what was your mean, what was your standard deviation, and they figure out what your SAT score should be. This is exactly what they do. So if your SAT score was 1250 and their cutoff was 1275 for the top 10%, you usually get a call and they say, you know, would you be willing to take the SAT one more time? We'd like to see your score improve a little bit higher. We'd like to see at least another 25 points. And you say, you know, what is 25 points? But if that's where they put their cutoff, that gives them a better zone because if they have to kind of justify why you weren't in the top 10% and everything else is outstanding in your record, they need this to be up there too. It's just a criteria that you set. Each group that you do is different. Each group has a different mean and a different standard deviation. This year's group may have a higher mean than last year, may have a larger standard deviation or smaller, may have a lower mean. So each group that takes that particular exam, they find their mean and their standard deviation and they make a cutoff. All colleges pretty much do that. So that's how we figure out all those pieces. But not a bad thing. I put it on the graph because I like you to see where this is going so that it makes sense to you. Top 5%, area to the right. Cutoff value for your z-score. We do the inverse norm. We plug it into your formula and we find that x value, 85, We're up to 75, 81 to 88. So we're in the 81 to 88, and 85 is right in there. So we know exactly where our cutoff is. So as an employer, I don't have to count anything. I don't have to stack them all up and then take 10% on top. I just look for their grade. If it's higher than that, I take them. Lower than that, I don't look at them. Okay? Okay, so you guys are going to try 1, 2. Try this one. To put this in perspective a little, we had to say that it is better to have a shorter braking distance than a longer braking distance, right? So even though we're looking for your top 1%, we're actually looking for the bottom 1% here because we want them to be the shorter braking distance, and we're going to say that's a better way to do it. So we take your 1%, we do your inverse norm, and we find your z-score to be negative 0.233, well on the left-hand side of your chart. So now we find that braking distance.
143.317. I have 11.89. So I put 9. 143.9.
So you got 143 point.
I got 142.8. I got
143? 142?
142.3. And how would you do that?
I'm not my calculator.
Now, let's take a look at this. If this X value, guys, watch. Now, I want to know what is the longest braking distance, but still be in the top 1%. How should I round this?
Down.
Down. Very good. So my X score is going to be 142 feet. Very good to round down, because if we round up, we're out of that. I want them down here. The rounding always catches us a little bit. Okay. Oh, I still have a few more minutes, right? Yeah. 5.
6.
All right. So, for homework, guys,
This is also tomorrow's classwork?
this is tomorrow's.
We have 2 classes.
Let's skip school.